Hey, I thought I would share some insight into the fat cells when it comes to insulin resistance. You guys know, of course, insulin resistance is the most common health disorder probably in the world, and it underlies a lot of the chronic diseases that we could call the plagues of prosperity. These diseases that are killing us that were largely once unheard of. So insulin resistance matters, is what I'm saying. Where insulin resistance starts in the body is a matter of debate. And so I want you to know that I point the finger at the fat cell as the tissue that falls first. It's the domino that first tips and then it tips into other dominoes. But this view that it starts in the fat cell, it's defensible. I'm pretty certain that's the right way. And I thought I'd discuss the fat cell for just a second in the context of insulin resistance. When someone is getting fat, or let's say we have two people that are getting fat at the same rate, they're both gaining 10 pounds per year. We have two different ways of getting fat. Fat tissue, what we can pinch and jiggle on our bodies, can grow through either each individual fat cell getting big, that's called hypertrophy, or it can happen through the individual fat cells getting a little big, and then they recruit new fat cells. So that's called hyperplasia, or the fat cells are hyperplastic. In the case of the hyperplastic fat tissue, it's almost like it's a hotel that always has vacancy. The moment a room gets full, they just build new rooms. So it's this limitless potential. In contrast, hypertrophic fat growth has a finite amount of space. They can reach a point of no vacancy because the number of fat cells is capped. It's set. But each individual fat cell has grown and, indeed, reached an actual point of maximum dimension, which comes at around 4 to 5 times the size of the normal fat cell. This hypertrophic fat growth is sick fat growth. Now, interestingly, it's also limited fat growth because there's this point of no vacancy. So this is a person who's getting fat and reaches a maximal point. In contrast, the hyperplastic growth can continue to go on. This hypertrophic fat cell, because it has reached a point of maximum dimension, two things start to happen that explain its insulin resistance and how it starts to spill the insulin resistance throughout the body. But interestingly, while this hypertrophic fat cell is attempting to survive and insulin resistance is a part of it, it actually makes the rest of the body suffer. So it's like the fat cell is being a little selfish in trying to ensure its own survival. And the two things are as follows. The first one, when the fat cell is reaching this point of maximum dimension, it becomes insulin resistant in order to ensure that it doesn't get so big that it bursts. And it does so by becoming insulin resistant, and namely resistant to what insulin's trying to tell it to do. Because you see, insulin is always force-feeding a fat cell. It's always pushing new fat into a fat cell. But what it also generally does is prevent that fat cell from breaking down its own fat. It inhibits this process called lipolysis. So insulin normally turns that off, and it won't allow a fat cell to leak its fat or to break its fat down and share it with the body. But this fat cell that has reached maximum dimension, it's still being force-fed the fat by insulin, but now it says to insulin, you want me to continue to grow and hold on to fat? I can't. So now I'm going to start leaking it. That we have is the first problem. The insulin-resistant fat cell starts leaking free fatty acids. Now, second, and important when we consider insulin resistance in the whole body, these individual cells, as they're all reaching their maximum dimension, we have fat cells that are getting ever pushed further and further away from capillaries, the blood vessels that are flowing through the fat tissue. And as they're getting further and further away from the blood, they're less capable at exchanging gases, namely accepting oxygen and giving their carbon dioxide, this kind of breathing of the cell. And so these hypertrophic fat cells become hypoxic. Now, in order to try to increase their blood flow in the fat tissue, to get more blood for these selfish fat cells that are just trying to survive after all, they start releasing pro-inflammatory proteins or cytokines, some of which will induce the production of new blood vessels, new capillaries. So the fat cell that has become hypertrophic is trying to ensure its own survival by becoming insulin resistant and pro-inflammatory. And it works. The fat cell survives, but the rest of the body has to pay the price for that. And then you have the brain becoming insulin resistant and dementia can ensue. You have the liver becoming insulin resistant, and then blood glucose levels go high and the liver becomes fat. You have other cells of the pancreas becoming insulin resistant, increasing blood glucose, and the testes or the ovaries has started to have problems, and so on and so forth. But all of it started at the fat cells that were just trying to survive. And unfortunately, that's how most people get fat. Most people, that'll be a topic for another time, talking about the timing in the life of someone where they set their fat cell number. Most people have a set number of fat cells, and thus hypertrophic growth of their fat tissue is the only way the fat tissue can grow. And then, of course, the fat cells get big and sick and insulin resistant, and the rest of the body follows. Anyway, now you know. Don't be too hard on the fat cell. After all, like I said, it's just trying to survive, but we put it in a difficult spot by all the calories, just the sheer amount of energy we're eating, and the chronically elevated insulin constantly force-feeding the fat cell to take in more fat and to get ever bigger than it was before. Now you know. Let me know what you think. Please share this interesting scientific tidbit with your friends. And as always, guys, thanks for tuning in. I'm glad to do the only thing I can, which is share some insight on human metabolic function.